Good afternoon. I'm Guillermo de Cervantes of the Shire of Southkeep in the Kingdom of Trimaris. We're presenting this class on basic blacksmithing. Before you is our instructor, professor, expert. This is Count Valbrandr of Trimaris. And he was literally raised in the forge by his grandfather. But he's been doing it seriously for the past 10 years. Thank you for joining us, and we look forward to this class. Thank you, Count Valbrandr, for joining us.
Not a problem. Thank you for having me. To answer a quick question that was just asked, I have a propane setup for right now. I plan on having a coal and charcoal forge here soon. But as Guillermo was saying, I've been doing this for the better part of 10 years, actually about 12. And metal is by far my favorite medium to work with as far as artistically. It's very forgiving and you can just about do anything with it. And so I've been, I started when I was 13 and carried that through, carried on throughout high school. And after that, my situation wasn't, I didn't have a good place to have, a setup like this. So I had to, put that on the back burner. And then probably about 7 years ago, I started putting forth a lot of attention and into creating the setup that I have now. I have one forge currently. I'm building 2 more right now. I've got 3 anvils set up, 3 anvils total set up. And I've been doing classes for the past 2 years with the local firefighters and just friends of friends and family and all that. It's just it's pretty therapeutic as well. You just kind of really just zone out and just kind of work the steel. And sometimes it cooperates, sometimes it's not. But anyways, we're going to get on to the class today, and today we're going to be making a set of hinges for a Viking chest or rowing bench or whatever you want to call it. So with a propane forge setup, it's obviously not what they had in period. What they would have used is charcoal. And charcoal is reduced, wood that's been reduced down to, almost pure carbon and without a whole lot of impurity. So it burns very clean and it burns very hot. And they didn't, at the time of, the Viking Age, they didn't have coal. They hadn't discovered it yet. So charcoal was the primary source of fuel. This anvil right here is not one of period either, but the basic concept still remains. As well as with the forge, we use fuel and to make fire to get the metal hot. And this anvil is just a big block of steel to hammer on. And again, even with the hammer's a modern design, but still the basic concept is there. The only things that haven't changed a whole lot are tongs. Tongs are, just large, robust pliers to help carry and manipulate the hot steel, and they really haven't changed all that much. They've got one job, and they do their job quite well. So again, we're going to be making a set of hinges, and what I have here is a solid bar of mild steel. It's not unlike what you would. Sorry, there's a. I don't know if you can hear that, but we have a park across the way, and people like to play loud music and rev their engines. But anyways, hope that's not too distracting. But here I have this piece of steel. It's just mild steel, nothing too crazy, nothing too important about it. And it's a 3/4 inch by 3/4 inch by 4 inches long. And honestly, this isn't much unlike what an ingot of iron would look like in period. Iron would have been used for these hinges, some of the lowest grade iron, actually, because in that time, it was very difficult to create steel of good quality. And so that steel, not only would it be difficult to make, it'd be incredibly expensive. So that steel was predominantly used for weapons. And then the lower forms of steel and iron were used for armor and tools and different things of that nature. So, so I have this piece here. I've got 3 more pieces in the forge already getting hot. Of course, I got my anvil, I've got my hammer, and I've got 2 sets of tongs that I'm going to be using to hold the steel. That way, I don't have to hold it in my hands, obviously. And I have this here. This is just a round punch. I think this is a piece of mild steel in itself that I made real quick. And actually, this isn't much unlike a punch that was found in the Master Mirror find, which is a huge research resource that a lot of metalsmiths use for period metalworking. It was a big chest was found, and it had all different kinds of tools and all different kinds of chains and different things like that. So it was really important. It was a really important find to see what kind of tools that was made in that time and stuff like that. So I'm going to stop talking. I'm going to get this last piece in the forge, and going to get going. So first, what I'm going to do is I'm just basically going to flatten this out and get it closer to the shape that I'm going to need. So since I have 4 pieces in the forge, I'm going to be working pretty continuously. So if anyone has any questions, just please feel free to type them out in the chat, and Guillermo will get to me.
Now, Valbrandr,
Yes.
can you talk a little bit about how to set up a forge?
Oh, absolutely. So it is what you make of it. As with a lot of things, whether it's a hobby or even the SCA as a general. So there are definitely cheaper ways of going. I mean, you can look online and YouTube and stuff like that, and find that there's pretty cheap ways to come up with the equipment that you need. I've seen people, they'll dig a hole in the ground and they'll run a piece of metal pipe through the ground and and attach that to a hair dryer, and then they use either barbecue grill charcoal or lump charcoal from the hardware store, and that's your heat source, and that does pretty well actually. And there's cheaper ways of coming about using an anvil or an anvil shaped piece of steel. I mean, this one was made in 1903. It's 433 pounds, and it's my baby. It cost me quite a lot, but I love it. But there are cheaper ways of going about it. You can, a lot of people will use bits of railroad. That works perfectly fine. There's nothing wrong with that. Can be a little bit loud, but there are ways to make it not quite so loud. And even I've been able to find big chunks of steel. Actually, I've got a big chunk here. So this is just a big chunk of mild steel that I bought on eBay for $50. It's just it's called a mill drop, where a big industrial, factory or whatever needed a piece of this size, but it was a little bit too long. So they cut this part off, and instead of throwing it away or whatever, some people will, will sell the pieces. So if you go on eBay, look for mill drops or lathe drops, and you can find stuff like this. And there's absolutely nothing wrong with this. It'll totally work for what you need, and it's a great avenue to get you started. And this was $50 with plus shipping, so $65. You could have a big chunk of steel like this that could last you for years. Again, with the hammers, you can use, you can go to Harbor Freight or any hardware store and just get, some machinist hammers or whatever, and that'll get you started. As far as the forge, like I say, dig a hole in the ground and use charcoal. Or some people will use cast iron brake drums, and you can, that takes a fair amount of metalworking skill or knowledge to do something like that. But again, it's very easy. That's how I started. I had, just a couple of pieces of rebar, a couple of pieces of pipe, and a big cast iron brake drum, and that served me well for 5 years, and with little to no upkeep at all. So I built it once, and it did great for me. And you can also go online. There's all different kinds of places on online, whether it's Amazon, eBay, other personal websites of people where they build stuff for they can build stuff on a budget. That way you don't have to invest quite so much to get started. And I've seen a lot of people go that route, and it works quite well, actually. So when I started, my grandfather had an anvil, and so luckily I didn't have to invest in that. But everything else was just stuff that he had laying around. So it is what you make of it. So
How important is it to be outdoors?
how important?
Mhm.
Well, I like my setup outside because I have a really, really, really nice place to work. Some people work inside, whether it's up north and there's a good part of the year where it's snowing or just bad weather in general. So you could do it inside, but then you have a heat source spitting out you could any shop or building or whatever that you work in can get quite hot pretty fast. And for something like that, there's a fire safety aspect that you have to always take. I've been in the community. I've seen dozens of shops burn to the ground, just from people being complacent or, just taking all the precautions that they could, but, something bad happens still. And it's quite unfortunate, but if you want to do it inside, totally can. There's a lot of people who do, but you have to take into account the fire safety, because if you have a detached shop or garage, then hopefully if something happens, hopefully only the shop burns down. If you try to do it in your car garage that's attached to the house, that brings in a whole different set of risks. If a fire were to get out of hand or something like that, that could very well spread to your house. And so you want to be smart, because there are people who make money out of this and who can make a living, but you don't want to burn your house down or burn a shop down over a hobby. So there are a lot of precautions that you have to take if you want to do it indoors. But with me, see if I can get a decent picture here. This is my view. That's
Damn.
And this is why I do it outside.
That's a gift.
It really is. I'm quite thankful for the view that I have. Any more questions before I get started again?
What are some of the basic fire safety issues that need to be considered?
Well, so it just depends on your fuel. I'm using propane, and most people use propane because it's a cheap and easy form of fuel. So residual heat, I mean that forge is going to be hot for hours. So you don't want to shut everything down and throw your apron on top of it, or whatever. You don't want it close to anything combustible, like a wooden like a wooden wall or something like that, where heat could radiate to that combustible material and it slowly starts smoldering. Even if you have like a metal shed with insulation in between, that the radiation, the heat radiation coming off of that forge could transfer in through the sheet metal and start the insulation to start smoldering. And just because it doesn't catch on fire, within the first hour or two, doesn't mean that it's not going to. And so, you always want to have, either a water hose on hand, or, in case of, an incipient fire or something like that, you always want to have a water hose. A fire extinguisher could be useful depending on the situation, but most of the time water's going to be your best bet, because you can put if the heat radiates from your forge to like a wooden wall or something like that, you can put the wooden wall out, but the heat source is still there. So you have to cool down whatever the heat source is, and usually that's going to be either a knife that you were working on that got set too close or set on top of something combustible, or even the forge. Also with the propane forge, you've got propane lines that runs from your tank to the forge. Yeah, you got to keep those well out of the way of any heat source. So you have to take that into account, because you don't want the residual heat coming out of the forge to burn through your propane lines, because that would obviously be bad. Going into solid fuels like or charcoal or coal. Coal's pretty safe. It's pretty stable. It doesn't really give off sparks or really bad fumes or anything like that. But you try to do like a coal forge, depending on the quality of coal that you have. Whenever you go to add more coal, or even just start up your coal forge, it will give off a thick black smoke. So if you don't have an exhaust system or something like that inside, then that can be problematic. And for charcoal, like lump charcoal or something like that, it gives off sparks. Whenever you're running a blower to add more oxygen to the fire to make it hotter, it will throw sparks. So, if you're doing, again, if you have a wood building, or, God forbid, a barn or something like that close by that could have hay in it or something like that, then that definitely has to be taken into account. So, just most of it, honestly, is just going to be common sense, as far as fire safety, and, not being complacent. That complacency is a killer. And it's a killer in all industries, including this one.
I imagine if you're distracted, that could be a threat as well.
Oh, well, that if you're distracted, that's more of a risk to yourself, because I've come close to really injuring myself a few times from being tired, and it's at the end of the day, and I've had, I've fumbled pieces of metal and, hot pieces of steel. And I've even had one time, again, importance of, safety. I had a pair of just regular sunglasses on for eye protection. And at the end of the day, I was tired. I was, I just wasn't paying attention like I should have. And the knife that I was working on flipped out of my tongs and actually struck me right across the face right here. Now, if I hadn't had my glasses on, then it definitely would have blinded me in this eye, because that's exactly where it hit. And it hit with such force that it actually broke the frame of the glasses, because they were just run-of-the-mill sunglasses. They weren't actually safety glasses, but they saved my eyeball, so they still worked. So, the safety, the personal safety for yourself is definitely something that you have to take into account. This metal's hot. There's no way around it. And if it's not glowing red hot, it's still going to be hot. You'll still burn the absolute crap out of yourself. And different things, when you're working outside and it's bright, you can barely see the forge there. There's actually a tail of fire coming out about 10 inches out of that forge right now, but it's just so bright you can't see it. So, you can brush your hand a little bit too close to it, and it'll take the hair off the back of your hand. Or if you're moving a little bit slower, it could give you some first-degree burns. I've burned the crap out of myself. I can't tell you how many times. So PPE is always something that you need to take into account. Wear proper safety glasses, and earplugs or earmuffs. I prefer earplugs because I tend to get really hot and sweaty. But these is obviously to protect your ears. And any kind of power equipment, power tools, whether it be drill, grinder, whatever. You make sure you wear your proper PPE with that. Some people prefer to wear gloves. I don't. I just treat everything hot. So I've actually burned myself worse wearing gloves than I have without them, if that makes any sense whatsoever. But I just treat everything hot. So, if it was in the fire within the past couple of hours, then it's going to be hot. And so I always test it, make sure that it's not. So, but yeah, fire safety and personal safety are always should be at the forefront of your mind whenever you're working with stuff like this. All right, let's get back to work.
Valbrandr, can you hear me?
Yes.
I noticed that when you were working, you flattened the metal and then you turned it on its side and you hit it on its side. Why were you doing that?
Well, what that was doing, as I was flattening it out, it wasn't flattening out evenly. So I turned it up on its side to square up the edges again. Just keeping it all in a nice uniform rectangular shape. That's all.
Are there different uses of the anvil depending on where you're working?
Oh, absolutely. You can use the corners here to isolate where you're hitting. You can use the hornway out here. And so basically, whatever the hammer does on top, the anvil does from the bottom. So when you hear someone talking about the rebound of the anvil, that's what they're talking about. Is a good quality anvil will have a good rebound, and that basically the force that you put into the piece with the hammer gets bounced back on the underside through the anvil, and it basically kind of like doubles your work that you're doing. So with this anvil, I've got a big horn over here, and by placing the piece of steel on the anvil, I'm decreasing the surface area, which increases the PSI of the force that I'm trying to exert, which moves a slightly smaller section of steel much faster. So it's a faster way to work. And you can do something very similar on the corners here. So yeah, and this square hole right here is called a hardy hole. You can put different kinds of tooling in here to do different jobs and stuff like that. So there's a lot of different things that you can do with an anvil. It's not necessarily just a big block of steel.
There's another question. How do you tell if your propane forge is at the correct heat without a thermostat?
The only temperature that you really have to worry about is when you're trying to forge weld, and forge welding is basically getting two pieces of steel very, very, very hot and binding them together and making them one piece of steel. And that's pretty much the only time whenever it's really important to know what the temperature of your forge is. Otherwise, you just basically go off the color of the steel. Right now, mine is basically like a bright orange right now. So that's definitely well within a good working temperature for the steel. It's nice and soft to where it moves very well, but it's not so much, not so hot that it wants to try to fall apart on you, which it can. You get it close to its melting point and you hit it really, really hard, and it's gonna fall apart on you. But with 99% of propane forges, they don't get hot enough for that. So that's not something that you have to really worry about. However, a coal forge or a charcoal forge, if you turn your back for too long, you'll end up with a puddle of steel in the bottom of your forge. Especially with charcoal, or I'm sorry, coal. Coal burns very, very hot. And that's an additional skill you need to learn is controlling your fire inside the forge, because and I can go off on a big long tangent on that, but yeah, charcoal and coal can get much hotter than propane. So propane, it's not too important. You just kind of go off the color of the steel if you're just doing regular run-of-the-mill forging. edge of the anvil. And I don't know if you can see this. Right here, you have a couple of lines. And what that is, those are where the metal is being pinched in a very specific area. And it just works the steel a little bit faster. All right, so this piece I've made most progress on. And from here, so I'm leaving this area a little chunkier than all this bit. So this part will be drawn out real long and thin. That way I can turn it back on itself and it'll be 1/2 of a hinge. Always a good forum workout, that's for sure.
Cal Valbrandr,
Yes.
this is a beginning class. What kind of project would you see for an intermediate class?
For an intermediate class? Well, I mean, you do like a small knife called a puko, and that's a Scandinavian style utility knife. Even a project like this with hinges, it can. What I'm going to be building is going to be pretty basic and not too complicated, but there have been finds where the hinges have all different kinds of decorations and file work on them and stuff like that. So you can definitely take something like a project like this that's fairly simple and kind of take off and run with it and turn it into something something pretty ornate. I know Papa Thunder, he's my Laurel, and I've been talking with him about different class ideas and whatnot. He likes the he likes making having his beginners classes do like steak turners and forks and stuff like that, and those are fairly similar or fairly simple rather. So definitely wouldn't be making any kind of tongs or something like that. I just a decent set of tongs. So yeah, blades and different kinds of knives and stuff like that, or heck, even hammers. Hammers could be a fairly simple, just depending on the design of the hammer.
What is the weight of your hammer?
An intermediate. This hammer here, it is 3.5 pounds. This one here, but I've got smaller hammers. I've got bigger hammers. Okay, I'll show you.
I think he's going to get the hammers.
So I've got, this is a hammer that I use fairly often. I think this is even like a 3/4 pound or a half pound. I don't even think this is a whole pound. But it's got a very specific job that I can't necessarily do with something like this. This is one of my larger hammers. This is used to 2,000 grams. So that's almost lost you. The wind almost blew the camera over. So this is 2 kilos. So this is about 4.5 pounds here.
So we got a few comments. Eileen Bruce is saying, as someone who will be starting soon, what is a good striking technique to make sure I'm hitting the metal the way I want?
Okay, all right. So whatever hammer you decide to use, smaller, larger, whatever, I always suggest going with a smaller hammer. And whether you go and buy a blacksmith's hammer like this one, or just go to a hardware store and just buy a regular hammer, like a machinist hammer or something like that. The most important thing, I would say, is find out where the proper height of your anvil needs to be. And there tends to be some debate on that in, different forums and stuff like that online. For one, just find something that height that you're comfortable with, and a height in which you can strike the anvil perpendicular. You always want the face of your hammer to be perpendicular to the face of the anvil, because if you're striking, off like this or in either direction, for one, the metal's going to move differently, and in which case you need to either lower the anvil or adjust the way your arm moves. So a lot of people like to, so you can stand at a neutral stance with your hammer like this. So, okay, you guys can see that. So you want the top of your anvil to be just underneath the face of your hammer. So that way, whenever you're working like this, you're at the extent of your arm is where your hammer is hitting perpendicular. I like to be a little bit higher than that. I like my anvil because, you can see how this would be considered to be proper by some. But I like my anvil just a little bit higher than that because I don't like to be working this close to the anvil. Okay, I don't want this area to be that close to something that's red hot. So I tend to back away, which creates obviously some distance, but it also changes the where my arm will hit. So, but it's just one, wherever you're comfortable with, and two, you just need to make sure that your hammer technique is when you're just doing regular forging, you're not doing any kind of special manipulation of the steel. You want the hammer face to be hitting perpendicular to the anvil face. And always start with a smaller hammer. Work your way up, because like this is the hammer that I use all the time, and I've got 4 pieces in there. I haven't even touched the 4th one. I've only been working on 3 pieces, and my forearms are already burning. You saw me a little bit ago where I was hammering with my left hand, and that's not just because I was tired, but it also helps. One, it helps with dexterity with your offhand, and two, it gives your any questions? Any more questions?
Could you repeat what you just said? Our connection got bad.
Say again?
Could you repeat what you just said? Our connection got bad. When you said you sometimes use your left hand.
Oh, yeah. So sometimes I use my left hand to hammer because one, it improves my dexterity with my left hand, and two, it helps give my right hand a rest.
Robert left hand. He says his first forging class he ever took, he took rebar and made it into the equivalent of a butter knife.
Well, there you go. I mean, that's a fairly simple project, and rebar is a good tough steel. It's not a good knife steel, but it certainly is tough. So I actually use rebar for a lot of different. Almost lost the camera. I actually use rebar for a lot of tooling and different things like that, because it is just a really good all-around tough steel to use, and it's fairly cheap and easy to get a hold of. this piece, I'm going to isolate this chunky part and only draw out that section. So I'm going to come halfway off the anvil like this. And flip it. Kind of hard to see, but I only was hammering on this bit and it made it thinner and a little bit longer. Again, I'm isolating this little portion out. I still have to flatten this part out a little bit, so I'm going to do that next.
We have a few questions and comments.
You said there was a question?
Yes, one person, Ellen Roy, says, I know that blacksmith in the next kingdom teaches making an S hook. And it looks like Loch Lane says, what makes rebar not good for knife making? Why is rebar not good for knife making?
All right, so rebar is a structural steel used to reinforce concrete. It's used in construction, any kind of construction that requires, concrete and stuff like that. So want something, and now when you get into blade steels and different things like that, they're going to have a lot higher carbon content. Now for mild steel, that's what, so iron is the element that we're working with, and carbon is another element that's in that you can add to steel or add to iron. Steel is technically the name of the alloy. A mild steel or a carbon or a carbon steel is of course carbon. Mild steel tends to have, so it'll have an alloy number, and that's called a 1018. And the 10 is just a generic, it's a generic number that's designated for, it's a number designated for generic steel. And then 18 stands for the 0.18% carbon content in the steel. And then from there, you'll have, so you'll have like 1018, 1045, 1050, 1085, 1095, stuff like that. Now, all the 10s are the same. It all means the same. It's called the 10 series. And those are just, fairly generic, nothing too, nothing nothing too crazy with the alloys. So it's just basically iron and carbon. And then the second two numbers is the carbon content. So with a 1045, it's 0.45% of carbon in the steel. And then with 1050, it's, 0.5% of carbon. And that's all you need to really start increasing the hardness of the steel. So I'll kind of get off into a little bit of a tangent here. So whenever, when you're wanting to make a blade, you want a goodness, and hardness, of course, is for edge retention. Because if the knife is sharp until you use it once and then it's dull, it's not a very good knife. And if it's not very tough, meaning it can't absorb impact and it breaks the first time you use it, it's not a very good knife either. So, of course, you want a higher carbon content so you have edge retention. And whenever you do the heat treat, and the heat treat, when you heat the blade, so a person smarter than me can better articulate. You'll see it on Forge on YouTube, where they'll take a orange pot and then they'll dunk it in oil. And what that does is that it cools down the steel very, very quickly. And some magic and sorcery happens with the carbon. And basically by cooling it down that fast, all of the molecules contract on one another, and all the molecules are bound up on one another. And it's brittle like glass at that point. You can actually drop it, and if you drop it on, or even if you kind of like toss it down on your work table or drop it on a concrete floor, it'll break. And because the molecular structure in the steel is under so much stress that it takes almost nothing for it to just. It's a very, very hard blade. And so it will keep an edge very well, but it has no toughness. It won't flex. It won't slightly give under pressure. And that's the other side of the coin. So you'll then put it back into the fire or an oven. Nowadays we use ovens and stuff like that, and we heat it up to just depending on the steel, anywhere between 300 and 500 degrees, and we let it sit at that temperature. And basically what that does is that it relaxes the tension and the strain down to the molecular level. So it allows those molecules to relax, and just a tiny bit. And so
is that what they call annealing? Is that the annealing process?
No, that is not. But that's a good term. Annealing is where you raise the steel to critical temperature, where it becomes non-magnetic, and steel becomes non-magnetic, which is actually kind of cool if it gets hot. If it gets hot enough. So, but what that does is as you're working the steel, of course, the molecules are sliding over one another, and that creates a lot of stress inside the steel as well. So what you want to do is that you want to do annealing cycles where you heat it up very, very hot and then let it slowly cool. And what that does is that it helps relax those molecules and relax the stresses inside the steel. That way, whenever you go to heat treat, there's no residual, there's either no or very little residual stress in the steel. Because if you don't do that, there's a higher chance of warping whenever you go to quench it in oil, or it can break, it can crack, it can do all different kinds of crazy things. whenever you go to heat treat. So
We have a comment. Robert Left Hand says material data sheets will tell you the best proper quench media. Some material may be water quenched, where others hardened in oil. It could even be an air hardened metal.
that's correct. And a general rule of thumb for modern steels is to quench in oil. That's the safest route, because it cools the metal down a little bit slower. Water will tend to cool the steel down very quickly, which can create internal stresses. And air cooling, that's reserved for very, very specific types of tool steels and different things like that. So normally, a smith won't be dealing with any kind of air quenching steels. And if you have anything like what's called as primitive steels, which is crucible steel, iron that has been worked into kind of like a form of low carbon steel, or even tamahagani, which is the traditional Japanese type steels. Those are generally water quenchable steels. For whatever reason, primitive steels tend to be able to handle water quenching a lot better than modern steels. So modern steels are general rule of thumb. You can do oil quenching, and you can do water quenching with primitive steels. Any other questions?
Not at the
Yes.
moment. Oh,
Yeah,
Oh,
yes.
yeah. Yes.
So you're talking about heating and reheating, and you said critical temperature, and then you said up to 500 degrees. So the first thing you were talking about was, you said you'd heat the metal back up to 500 degrees and then oil, or around 500, and then oil quench it. And then when I asked the question about, is that the annealing process, then you said something about critical temperature. So in the range of temperatures, what are those? Where do those things fall?
Okay. So again, it really depends on the steel. But typically speaking, if I'm not mistaken, critical temperature for a carbon steel is maybe around, I think it's around 1900 degrees. And that's where the steel actually becomes non-magnetic. And an easy way to see if it's at critical temperature is try to stick a magnet to it. And that's what I do for when I'm heat treating. I will have a magnet close by, and I'll use that as kind of like a temperature gauge. So but yeah, that's what critical temperature is. Ah. Where? The wind almost keeps blowing my camera. Ah.
So what can you tell us about your anvil? That thing looks like a monster.
It is. It's a fermenting anvil, and that's the maker. It's got all the stamping on this side here. It was made in 1903 in France, and it is 195 kilograms, which comes out to be about 433 pounds.
Wow.
Yeah, it's quite the beast.
It sounds expensive too.
It was, but actually, it was expensive, but I actually did get a pretty decent deal on it. Typically, anvils are sold by the pound, and smaller anvils are, you definitely have kind of like a bell curve with all anvils. So smaller anvils, they're cheaper because they don't weigh as much, so you're not going to pay as much for them. So they're cheaper, but by them being smaller, you can have someone who, kind of either mistreats it or just, really puts it through the ringer through its life. And so you can damage anvils quite easily. I've seen where, these edges here, because a lot of people will work steel on the edges, and if you're not careful, so these hammers are hardened steel, and so is the anvil. So if you're not careful, if you hit hardened steel against hardened steel, one of them is going to break, or one of them can break, I should say. So with the hammer, obviously having more mass than this, this tiny part of the corner right here, it's very easy to chip off corners of an anvil. So, and some anvils will have a tool steel plate welded to a cast body, and sometimes anvils are mistreated so poor or so badly that steel plate can come delaminated off the cast steel body and just completely fall off or chip or crack and all kinds of stuff. And that's when you can really tell it's been mistreated and worked really, really hard. Back in the Revolutionary War, the English would go through and they would break the horns off of the anvils because you use the horn to make gun barrels. And so they would break the horns off the anvils to help slow down the production of colonial guns.
How do you break a horn?
You hit it incredibly hard. You take a hammer like this and you just hit the horn until it falls off. And it's not necessarily easy, but hell, you could probably even use another anvil to break the horn off. But that's what they did. And I've come across a few that were mistreated, and it always makes me shed a tear. But being a blacksmith, I actually have two professional blacksmiths in my family history. I was able to trace it back all the way to 877 and in Wales, and so it's actually kind of cool that I have some history in blacksmithing in my family. But anvils are very special to blacksmiths, and you can, some people can be like, oh, this is a hobby and this is just a chunk of steel that I'm going to hammer on, and some people think of it more than that. And I'm definitely one of those people. That this is a tool in which you can create beautiful things, and whether it's art or a weapon or whatever, it's a form of beauty no matter what. And the Irish, it's actually traditional to be married upon an anvil, because blacksmiths, I forget the time period, but in Ireland, blacksmiths were also ordained to hold marriages. And so that obviously increase, obviously adds to the significance to anvils, especially in Irish cultures.
I have Robert Left Hand says, I've seen a couple with the tail broken off, which also left the top plate damaged.
Yep. Somebody was probably, again, mistreating it or working it way too hard, and they broke the heel off. This portion is called the heel, and that can break off just as easy. It's I always shed a tear because they had a hard life.
Thank you.
I'm going to repeat what I just did. I'm going to make a mark right there. Not sure if you guys can see it, but I'm going to work this part right here, and I'll show you how much the steel will move. So I don't know how well you'll be able to see this, but this is where that line was before I started hammering. So this was the shoulder, and I didn't work that area. And this is basically how long it was before. So I was able to increase the length by that much. So I went ahead and pulled the other two pieces out of the fire that I haven't really worked on too much. So just for time's sake and there's no point in just leaving those in the forge just to bake. Basically what I'm doing, I'm gonna try to draw this side of the end here so you can kind of see. So I just had just a regular block like this. I'm not sure if you guys can see it, but just a regular block of steel. So
We can see it fine.
I'm drawing out